In this video, I want to prove the identities turning a sum into a product or vice versa. So these are basic identities that will, I guess, go from the sum and difference identities for sine and cosine. And then, suppose we have two angles u and v, or two real numbers u and v. Is it possible to find real numbers a and b that satisfy the set of simultaneous equations? Yes, because if you instead of x and y, a and b, here's our y-axis and our b-axis. These would describe lines in the plane that one is a 45-degree line and one is like 45 degrees the other way, so they make an x, so there is an intersection, so this does have a unique solution. Once we know that, then we can plug in these identities. So if we look at the first one, and I guess you should memorize these, you should have these memorized. So the first one, a plus b, I'm just going to plug in u, and it turns, remember on the right side here we have a. Well, you can see if we add these and divide by 2, we get a, and for b, if we subtract them and divide by 2, we get b. So my first identity translates into this, right? Let's verify that that's correct. And then the second identity gives this. This is a v, and then this is the same thing, basically, except for this minus sine, sine, cosine, cosine, sine, and then the plus, the minus, the plus, and the minus. Now, if we basically add these two identities, we get this right here. If we add these two equations, we get this. Sine u plus v over 2, cosine u minus v over 2. This 2 can be here or here, but notice this allows us to go from back and forth between a sum of two sines and the product of two sines. And we can do similar for cosines. So you could almost do this in your head. Again, I'm starting from these basic four, namely the latter two. And we're going to add them together, and we get cosine u plus cosine v is equal to 2 cosine u plus v over 2 cosine u minus v over 2. All right, please support me through PayPal to devinwyndham@gmail.com. I also do tutoring, both online and in person. I'm based in Fairfax, Virginia. If you're interested in tutoring, you can contact me at this email as well. Please subscribe to my YouTube channel.